Hello everybody and welcome to Unit 4, Day 4. Today we'll be talking about inequalities in triangles, but before we start with that, I just want to do a little refresher on solving inequalities for you. So here we go. When you're solving an inequality, you solve it the same way you would a regular equation, except there's one thing you need to remember. When you multiply or divide by a negative number, you must remember to change the direction of the inequality. So if it was greater than, you'll change it to less than. If it was less than, you'll change it to greater than. So let's do a couple of examples here. Here we have negative x divided by 3 is less than or equal to 11. So to solve this, we're going to multiply each side by negative 3. So here, the negative 3 times negative x over 3, the negative 3's will cancel and leave you with just an x. On the opposite side, 11 times negative 3 gives you a negative 33, but in the middle, our less than or equal to sign has to change to a greater than or equal to sign. So x is greater than or equal to negative 33. Example number 2, we want to solve for x again. So we have 8 minus 2x is greater than 24. First we'll subtract the 8 from both sides, which will leave us with negative 2x is greater than 16. And then we'll divide by negative 2, giving us x is less than negative 8. So when we divide by the negative, we have to switch the direction of the sign. Compound inequalities consist of two inequalities joined by and, or. Here are some instructions on how to solve them. Inequalities with and can be written as one expression. You'll see examples of that in just a little while. If they're written as one expression, you're just going to perform the same operation to each part. You're going to flip the inequality if you multiply or divide by a negative number, simplify, and you want it to be in the form that it was first written. So here's an example of that. We have negative 7 is less than negative z minus 1 is less than 3. First, to get the z by itself, we're going to add 1 to each part. So we have to add 1 to the negative 7, to the negative z minus 1, and to the 3, which leaves us negative 6 is less than negative z is less than 4. Then we're going to divide by negative 1, and again, since we divide by negative, we're going to flip the inequality. So negative 6 divided by 1 is positive 6, 4 divided by negative 1 is negative 4, which leaves us with 6 is greater than z is greater than negative 4. Example number 4. 25 is less than 3x minus 8 is less than 52. First thing we'll do is add 8 to both sides. Which will give us 33 is less than 3. I'm not sure what that little line is there. Is less than 60. That should be an x. I'm going to put that in while I'm talking to you guys right here because I can. Then we're going to divide both sides by 3, or all the sides by 3, which will leave us with 11 is less than x is less than 20. In this particular one, we're not switching the direction of the sign because we're dividing by a positive 3, not a negative 3. So I bet you're wondering how this applies to triangles. I'm glad you asked. There's two concepts we need to talk about, the longer side concept and the larger angle concept. The longer side concept simply states that the longest side of a triangle is across from the biggest angle. So, what we have here, since AB, which is 8, is greater than BC, which is 5, the angles across from them are going to have the same relationship. So side AB is 8. If you cover up AB, the only angle you can see is angle C. So that tells us that the measure of angle C, we have the same thing as greater than. If we cover up BC, the only thing we can see is angle A. I keep grabbing little pieces here instead of the triangle I'm looking for. There we go. So the measure of angle C is greater than the measure of angle A. The larger angle concept tells us that the larger angle is across from the bigger side. So it's the same thing. Here we can see angle A is 50 degrees, angle C is 30 degrees. If we wanted to, we could use the triangle sum theorem to figure out the measure of angle B, but it's not important right now. But we can see that the measure of angle A, which is 50, is greater than the measure of angle C, which is 30. So if we look at the sides across from them, the side across from A is BC, the side across from angle C is AB, so BC is going to be longer than or greater than AB. So if we had a triangle like this, where we have three angles, sometimes we won't have all three, sometimes you'll have two and have to solve for the third. But here we have all three. It asks us to list the sides of triangle RST in order from shortest to longest. The smallest angle in this triangle is angle R, which is 29 degrees. If you cover up angle R, the only side that you can see all of is side ST. So since that's the smallest angle, that must be the shortest side. The angle in the middle is 30. 30 is at angle T. If we cover up angle T, we can see side RS. And angle S is 121 degrees. If we cover that up, we can see side RT, so that must be our longest side. Remember, side lengths are two letters. They're segments with a line over them. All right, this picture is a little more confusing, but let's see what we can do. So we have these two triangles put together. We're just going to look at them one at a time. So here we're looking at angle WXY and angle XYW. So WXY is this angle. XYW is this angle. You can see that WXY is across from the side that's 14, and XYW is across from the side that's 12. Since 14 is greater than 12, that means this angle must be greater than this angle. So the measure of angle WXY is greater than the measure of angle XYW. Now to look at the other triangle, we have angle XZY, which is across from the side that's 15, and angle XYZ, which is across from the side that's 18. What's bigger, 15 or 18? Good, it's 18. So that means that this angle must be greater, but we want to keep it the way it's written. So XZY is less, oh come on, I'm really fighting here with this thing. So the measure of angle XZY is less than the measure of angle XYZ. This last one, angle WYX and angle XYW, I'd like you to try on your own. See if you can figure out which angle is bigger. The triangle inequality theorem in words says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. For our purposes, what I want you to do is find the two shorter sides. You will add them together. That number must be greater than the third side. If it is, you can make a triangle. If it is not, you cannot make a triangle. So let me go over a couple of examples of these. I will let you do a couple of examples on your own, and we'll talk about this stuff in class. So first, a triangle has one side length of 12 and another of length 8. Describe the possible lengths of the third side. Well, what we're going to do with the two sides we know, we're going to subtract them and add them, and the third side has to be in the middle. So this is where our compound inequality came in. So 12 minus 8 is going to be less than x, which represents our third side, which will be less than 12 plus 8. So 12 minus 8 is 4, 12 plus 8 is 20. So our third side, which represents x, has to be greater than 4 and less than 20. To put the triangle sum theorem to the test, can the following three side lengths form triangles? So first we've got side lengths of 1, 2, 3. So 1 plus 2, since those are two smaller sides, equal 3. 3 is not greater than 3. So we cannot form a triangle. Number 2, we have 2, 2, and 3. You may notice something since these two are the same, but we'll get to that later. But 2 plus 2 equals 4. 4 is greater than 3, so we can make a triangle. I want you to see if the side lengths in C can form a triangle. The other questions that remain we are going to discuss together in class. I hope you had a great video, and we will see you soon.